You get a sense of urgency as to how the ports are growing and if they're going to stay up to date, what they need to do, and they're doing that. Obviously, Port of LA is rated #1 with the container moves and all that, and they're doing a very good job. And other ports, one way or another, they're following through that process. You also heard the Luskin report as to how electricity needs attention, to summarize everything that you heard. So there are opportunities to do. What I would like to do is deviate a little bit and try and concentrate on one idea, one thought, on how to put all this together for all of you who are here to try and benefit from it the minute you walk out of that door. You start earning your salary as a consultant to the ports or the operators or as a manufacturer. Whatever business you're in, if you're interested in the port, I'm going to try and give you one idea, and if you can grasp that idea, it will help you in being successful in participating in a lot of these opportunities here. Now, this one says Part 3. You might wonder what happened to Part 1 and 2. Stan and John tell me that you guys all passed Part 1 and Part 2, so we're going to go into Part 3 directly. Okay, what was Part 1? We had a similar opportunity, and as I said, they give you little time, and I can't really give you all the benefit of this simple idea, so I had to concentrate on one, and that one was I showed them how to reduce their electricity consumption by from $120,000 down to $32,000 by applying this thought. Very simple. Everybody wants to do that, and we did that in Part 1. Here, since you passed it, you have to accept that. In Part 2, I was in a different group, and there is one similar here, apparently in solar panel, that if you're involved in a port activity, and as you heard Vivek said, they're interested in solar activities also, just imagine the port comes to you and says, I've got a job that requires 90 kilowatt of solar power system. And you take this idea that I'm going to give you and say, you look into it and say, port, instead of 90 kilowatts of solar panel to put in there, we're going to put in 25 kilowatt of solar power, and it's going to do exactly the same thing. You're going to get that job compared to the other guy who comes in and says, okay, I'm going to do 90 kilowatt of solar power system. So that's the idea. So we go into Part 3. You have to accept Part 1 and 2, but Part 3 is going to be similar to the Part 1 and 2 with this idea that I'm going to share with you. In Part 3, basically, you're going to end up showing to the port or your customer or the terminal operators that they don't have to have any equipment to maintain, and the port terminal is going to operate just fine. Just imagine that your customer hears that. Nothing to maintain, and it's going to operate just fine. And no possibility of accident. You know, you don't have equipment, you don't have anything out there to trip on it, so there's no accident. How could you have any accident? No lawsuits or anything. You don't have any files to maintain. You know, you don't have to worry about OSHA coming in and say, show me your file. There's nothing to maintain. No permits to take on this idea. Nothing to do. And don't you think your customer would like to hear that? Anybody would like to hear that. They're operating their terminal, and they don't have to worry about anything. Okay, that's the end of my lecture. 10 minutes, and I have to give you the answer. The answer is very simple. Nothing technical. This is the answer. You heard Luskin report saying that reefers consume 15% of total energy consumption and all that. All you need to do is decide to use 15 kVA per reefer outlet. Each reefer outlet is 15 kVA. That's all you have to decide. Nothing really very complicated, but I can see the looks on your face like, what the heck is he talking about? How could it be that simple and no equipment and all this? So that's why I'm obligated to give you a little more explanation, and I'll try and give you that explanation. But that's really all you need to take out the room. Remember that. 15, not 13, not 16, nothing else, just 15. Okay, this is what we call reefer installation. This is a typical reefer installation. If you've been involved in the ports, we've got thousands of these things all over. And we've got these installations. It's necessary that when a container comes with refrigerated goods, that they be plugged in and stay refrigerated. There is no choice. Just so we don't get confused with these things, I know you heard a lot of kVA, kilowatt, and all these numbers. Let's simplify it and let's all be on the same page. kVA stands nothing more than kilovolt ampere. That's what it is. But you probably have heard the kilowatts more often. And kilowatts, basically 1 kilowatt is a 1,000 watt. You've heard about the light bulb in your house. You change it from 60 to 100 watt. That's the same thing. It's what? It's just that, in our case, that one outlet is 15,000 watt. That's what happens to be. Okay. Now, to simplify it even more, there's absolutely nothing wrong if you think in this particular example that kVA and kilowatt is the same thing. Don't worry about it. No fancy numbers or anything like that. It's the same number. Now, you heard a little bit ago that apparently in Port of LA they drink a lot of beer, so they have to associate power factor with foam and all these things. But I have to give him credit. That's a good analysis of showing a little bit the difference between kVA and kilowatt. But forget the foam a little bit and think that it's all beer. That's okay. Nothing wrong with that. And that's what we're talking about here. Okay. Now I'm going to try and show you the significance of that 15 kVA. And the way I can do it is by giving you an example. We're developing these terminals. You heard we've got big terminals coming in and they're getting bigger. When I started the work at the port, 5 acre was a big terminal. Then 60 acre became bigger terminal. Then 100 acre became a bigger terminal. Now we're talking about 400, 500 acres, and I don't know where it's going to stop, but they're getting bigger and bigger. With that, the first thing is when you're building a terminal, you're going to design some reefer outlets. There's no choice. You have to. The question comes up in any design, any manager knows that. How many? How do we decide that? Basically, we look at our existing terminal. We say we have 500, and we make a prediction for the future. It's going to be bigger and all these numbers that you hear, and we say make it 3 times bigger, 4 times bigger. So we decide 3 times bigger. It's 1,500. So that's about all the decision we make as far as accurate analysis of how many reefers we need. That's pretty much what it goes on when we're developing a terminal. And when it comes to electrical, it's magic in the port. It's done. The drawings are prepared and completed, and we end up with a reefer installation. There's one criteria for electrical design that you need to complete. It's impossible to take the 1,500 reefer outlets and start designing electrical plant. It's impossible. You need the kVA. Somebody has to decide that kVA. Ask around and find out, besides Vahik and I, who decides on what the kVA is. Luckily, we're together on that. And you're going to get blank stares, like, it's done all the time. We've been doing it for 40 years. Who's going to be that decision maker? How is it coming around? Now, out of curiosity, after all these years, I've sort of looked into it recently, just out of curiosity to see what others are doing. And the answer came out to be these numbers. So any number would work. There is no standard. There is no code requirement. You can put in any number you want to, and you can test this thing. You can put in 30, 1, 6. Somehow it will work. And at the end, you're going to get this set. This is a set of drawing and a set of spec. And it's a small job. It involves only reefers. And that's what it takes to do it. The number 15 is someplace in that area, and all the checkers and the quality checkers and all that, no one is going to go through this thing to try and determine what that number is. And if they do, if they come across it, they're probably not going to have any second thought on as to whether it's correct or not. And where do you find that in here? I happen to be cheating here, so I put a sheet of paper. It's on one sheet like this with a whole bunch of numbers. Not too many people are interested in that. And it goes through. It goes through plan check, it goes through everything, and everybody is happy with it. But you must think that there's something wrong with these things. Like in the Luskin report, I don't know what they took. If they took 25, they overestimated. If they took 9, they underestimated. The right number is 15. I gave you the answer already. Any other number anyone else uses, you should challenge them. Okay, what is the significance? Let's take a look at it. At 15 kVA, we decided we're going to have 1,500 reefers. Not a big math. You just multiply the two numbers and it comes up to 22,500 kVA. What Vahik was saying, you need 90 kVA and 90 megawatt and all that for the terminal, that's where it starts from. You need 22,500 kVA. And in any reefer installation, you have no choice, but you're going to put a transformer. It's impossible, particularly the terminals, they get large. You have to have a transformer some point to convert the incoming power, which is at high voltage, to the voltage that the reefer needs, which is 480. Now, I picked 2,500 kVA transformer, but for this discussion, it doesn't really matter what that transformer rating is. If it's less than 2,500, you're going to end up with more transformers. If it's more than 2,500, you're going to get less transformers. But the analysis and the idea behind this thought is the same. It's identical. So now we have 2,500 kVA transformer that we're going to be using, and each one can handle 170 reefers. It's a very simple math. You multiply 170 by 15, that's 2,500. And that's how many reefers that particular transformer can supply. Now, if you need if you're using 2,500 and you have 22,500 kVA total load, you divide one into the other and you end up with 9 transformers. That's really as simple as it is. It doesn't take a lot of genius to try and figure these things out. But you have to start, remember, from 15 kVA. That's the start. So with 15 kVA, you use 9 transformers. Now, if you go to the one extreme that I found out, the high extreme, 25, the same analysis. 1,500, now you need 37,500. You go through the analysis, now you need 15 transformers. Let's put them side by side so we don't need to think about it too much. We're talking about 100% demand. Now, that's an interesting thought. Everybody knows, but yet the calculations don't reflect that. We all know that. We don't turn all the lights on, all the outlets on, all the air conditioning on, all at the same time. But in this analysis here, 100% demand means all the reefer plugs are plugged a container into it, and they're all drawing 15 kVA each. It's an unreasonable assumption, but it's done often. So that's one thing to keep in mind. But keeping those numbers together, even then you can see that with the right number, you have 9 transformers. With the wrong number, you've got 15 transformers. 6 extra transformers that's doing nothing more than the 9 transformers you have at the installation. Nothing more. Okay, just think about that. Now, in part 1 and part 2, we went into this, and I said you can use 40% demand, and now you get 4 transformers instead of 15 transformers. It does exactly the same thing as the 15 transformers with 4 transformers. I have no problem with it, and Vahik will back me up too. There is no problem with that. But not everybody is doing that. Okay, Part 3 then is you're going to use 11 transformers less in your terminal when you develop it. That's the lesson. That's what you need to take from this forum here, that you're going to be using 11 less transformers. Therefore, no maintenance on transformers. Now, don't misunderstand me, okay? You're still installing 4 transformers. You have to maintain those. That doesn't mean you don't maintain anything. But the 11 that's missing, you don't have to worry about. And no possibility of accidents with those 11, no files to maintain, no permits to take. And you don't have to worry about those 11 transformers. You can imagine how much savings that is for anyone that's in the business. So in summary then, try and eliminate those transformers by using the right numbers, and try and use the 15 kVA each. And then with some encouragement, you can use 40% and use less transformers. Okay. The second thing I want you to take, once you have this thing in your mind, think about it this way. We are always in a rush. We are always not having enough time to give a talk or prepare drawings or whatever. And the challenge is you get this kind of a set, and as I said, this is a small set. You get maybe 3 times thicker set. They throw it on your desk, and they say you've got 5 minutes to review it. After complaining and all that, you realize you have only 5 minutes to review. What do you do? This is what you need to take. Any consultant here, any terminal manager, just imagine you can do this thing. You say, okay, I learned something at PortTech. What am I going to do? Find that sheet that I cheated a little while ago and say, that's not 15. Go back and use 15. You're done. Okay? Instead of arguing to give you 3 weeks and all that, you're not going to get it, but that's going to correct it. They're going to have to go back and redo that work. Now, you can't really locate that. You don't really want to. You don't have that patience. That's okay. The guy that dropped it on there, and ask him, what KVA did you use? And you get that stare look from him like, what are you talking about? Tell him, go find out what that is and show me in there. Now you're done with it. Okay, you reviewed the whole set in 5 seconds. And then you, as a consultant, you can charge them 3 weeks of work. That's okay. So he should come back and show you what that number is. And now, on the positive end of it, if you really want to, you can do it positively also. If you take the time and find out that that particular, let's say in your terminal, you have employees that are maintaining these things, ask him, what is the rating of the outlet? If he gives you that blank stare, tell him you need to look into that. But if he comes in and says it's 15 kVA and he knows what he is talking about, give him $1 increase per hour. He'll never forget that. It will make such a big difference in your operation. Just think about that. Just $1. And in a year, that's going to be what? About $8.40, about $2,000? He's saving you already $70,000 a year on your electricity. What's $2,000? Give him $4,000. That's okay. But again, no one does these things. No one thinks about these things. But that's the effect. That's the effect that you have. And it would make a big impact on it. So my conclusion is that as we grow, I gave you only one idea. There are thousands of these ideas, thousands of them. All you need to do is stand back, look into it, and simplify it. We're going to complicate it regardless. We're going to automate. We're going to do all these things. There's no choice. However, what I'm trying to point out is that there is opportunity for every one of us getting involved here. Don't assume that everybody is on top of everything. We don't have time to do that. No one has time. But find your niche and get into that and try and contribute to the process. And there are very many opportunities in doing that. That's all.